Okay, there's the ticket. Welcome back to Cloud 42. I'm James. This is my 6.5-inch Wilton Tradesman bench vise, and I love this vise. You've seen it in many of my previous videos. I use it for everything. I use it for hacksawing stock. I use it for hand tapping. I use it for assembly. I even use it to hold tool holders to set up tools for the CNC mill back here. I've got a set of magnetic bending brake jaws that I put in it for bending sheet metal. I use this thing for everything and I absolutely love it. The one limitation though is the hard steel jaws that came with it. Let me bring you in a little bit closer and let's take a look. These are the jaws that came with the vise and they're steel. In fact, they're relatively hard steel. File doesn't really cut them. They're pretty hard, which is what you'd want. They're pretty durable. And they're held in with two 5/16 18 button head screws in counter bores. Now these jaws are reversible. They have a smooth side, and I say smooth side, a relatively smooth side, and they have a knurled side. And if you use the knurled side, these things will put marks in everything, but they also hold really, really well. So if you don't care about putting marks in the surface of your part, the knurled side works great. I've been running the smooth side, but definitely if you clamp something that's aluminum, or even if you clamp something steel with a nice surface finish on it, they definitely mar it up. So that's the reason that I want to get soft jaws. The other reason is that the steel surface, because it's so hard, sometimes doesn't hold on to things very well. You get, especially if you have another hard part in here, it'll hold it, but it's real easy for the surfaces to slide. And so having a soft jaw to grip on that often gets you more friction with less clamping force and can keep things from moving around. Now, when I first got this vise, I thought, I'll make a set out of aluminum. These are 1 inch high and 5/8 of an inch thick. And so I got some 1 inch by 3/4 inch aluminum and figured those would make a nice set of soft jaws. I could make them a little bit thicker so that as they got marred up, I could pull them out and trim a little bit off with the mill and have a fresh surface again. But the more I thought about it, the more I didn't like the idea that I'm going to get a bunch of comments telling me that I'm mispronouncing aluminium. So I decided instead to use copper. So I picked up a small piece of copper to use. Now for this particular vise, it's pretty tricky because copper is a relatively expensive material and it comes in 6-inch lengths and 12-inch lengths when you order through the usual channels like McMaster Car. But this is a 6.5-inch jaw, so you can't just buy a 6-inch length. You can't buy a 12-inch length and cut it in half, so then you end up buying a great big piece of copper. So what I did is I went out on eBay, because copper is a pretty expensive material, and looked at drops. And there are a bunch of people out there selling drops on eBay. So this piece is 1 inch thick, it's 3 inches wide, and 12 inches long. If you were to go to McMaster Car and order this, it's C110 copper, it would run you about $200 before shipping at the time I made this video. I picked this piece up on eBay for about $85, including shipping. Why is it so cheap? The reason is because, now I can't prove this, but I strongly suspect that the reason it's so inexpensive is because somebody else already paid for it. This probably came from a job shop where somebody ran a job through, they had to go buy material, they bought them enough material for the job, they billed it to the customer, and then this piece was left over. So they didn't have a use for it because the next job that comes through that needs copper, the customer's gonna pay for that material. So rather than scrap it, you can sell it on eBay for a price higher than scrap price, but lower than new material. And so I pick up a lot of things this way, especially brass. This is the second piece of copper that I've bought that way. And especially these really expensive materials, you can buy them in drop form for a lot less than you can trying to buy them new from someplace like McMaster-Carr or even from your local metal supplier. So let me mark this up and take this over to the bandsaw and lop off a couple of hunks. Now, I was going to measure up the jaws, go into Fusion 360 and do a drawing, but when I went into the computer to look, I discovered I already did one. Apparently I did this several months ago. Looks like, yeah, the date was updated when I printed it. I'd already done one of these several months ago. I completely forgot. So this is what we're gonna do. Cut out a couple of pieces that I can machine down to 3/4 of an inch thick by 1 inch high and pop a couple of holes and a couple of counterbores in it, and we should be good to go. Now, the jaw is 1 inch high, and in the interest of conserving material, I am going to just use the natural 1 inch thickness of the stock. It looks a little mangled. I'll buff that up with some Scotch-Brite, maybe flat file it. It will be totally fine. It doesn't need to be machined on the top and the bottom surfaces because they're vise jaws and they're gonna get dinged up anyway, and I might as well save the full 1 inch height. I could do it the other way, run it this direction and either have them be 1 inch thick and cut a piece a little more than 1 inch high, but that's going to use up more of this material. And given the price, I will take a few pre-dinged vise jaws over having to use the extra material to make them perfect and then ding them up later. This is my 4x6 horizontal bandsaw. This is just a Harbor Freight special. And the saw actually comes with a table. You can pull out a couple of screws and mount the table on it, swing it up into the vertical position, and you can use it as a vertical saw. One thing that's not super great about the vertical mode is you can't bring the blade guide down far enough to really have it where you would have it on a typical vertical saw, but it'll work, and I'll be careful to keep my hands out of it. Now, I've marked up the blank here, and so I'm going to make a cut in and then make a couple of long cuts to pull out some chunks. And we're just gonna see how this goes. I honestly have not cut copper before on this machine, so we're gonna find out what happens. A little WD-40. Okay, there's one piece. Doesn't look like it changed shape very much. We can pull back and do the other one. I need to get into a better position though. Because this saw has wheels, when I start putting enough pressure on it to actually make it cut productively, it starts to roll away. So I'm holding the saw between my legs while I do this. So I'll find a better position and cut the other one, and I will meet you over at the mill. Got the blanks all sawed out. This one's got a saw cut on 2 sides, and this one's of course got the mill finish on one side and the saw cut on the other. And we are going to start with just assuming that the sides of the part that are just the mill finish are going to be what we're going to have on the top and bottom of the final jaw. And let's just flatten the saw cuts and get these milled to thickness. So I've got a single parallel I'm going to put in here, and I want the part to be pulled up against the fixed jaw and squared based on these mill finish sides. So let me make sure one of the sides of this was dinged a little bit. It's that one. I'll let that one float. I don't care if the parallel is loose, which it probably is. Yep, it is. All I need to do is flatten this side. Now I'm not sure what kind of end mill is going to work best on this. I've got some high-speed steel end mills. I've got a couple of carbide end mills. I've got some aluminum specific end mills, and I've got this one that I wanted to try, and this is an insert end mill. So this is 3/4 of an inch in diameter, and it's got 3 carbide inserts. They're not, super sharp, but I think they've at least got a chance on this aluminum, so let's give it a shot. Now I've got the mill head down low so that I can maximize the rigidity here, because the copper is going to be real gummy. Now the goal here is just to get a cleanup cut, so let's see what we can do. Let's see. Well, the surface finish looks all right, but honestly, it's gummed up a little bit. Let me put a little WD-40 on that, take a few more thou, and see what actually happens. We might actually need to use a different style of end mill on this. I'm really not sure. Oh, that feels much, much better. Well, the surface finish on that came out beautiful. I wasn't really sure what to expect machining copper, especially with these durable carbide inserts, but it looks to be doing very, very well. So the next step is to mill these to length, or to thickness. So I'm going to bring in a second parallel. Set the machine surface. I ran this across the Scotch-Brite wheel to deburr it on the edges. And we will run this in, make sure we're on top of the parallel, get that centered, and snug that down. Now I need to get that seated. And to seat things in the vise, I actually picked up some 1-inch copper rod. This is the same C110. This is a 4-inch piece. This is a 2-inch piece, so I can get in the confined spaces here underneath, and so I can feel how tight those parallels are. Oh, that is beautiful. Nice and tight. No move. Well, that one's a little bit loose because I just tightened the vise again. And try the 4-inch one, get a little bit more knock. It's hard to get under here. Oh yeah, nice and solid. Okay, those are nice. It's a lot easier than getting in here with a hammer, and it works a lot better than the dead blow hammer that I was using. So I'll come down and just clean up this side, and once I've got that, then we'll take a measurement, and we're shooting for 3/4 of an inch. And one thing to note here is because the cutter's turning clockwise, I'm going to come across the front edge first, so the cutter is cutting into the edge so that it doesn't raise very much of a burr. If I went across the back edge first, the cutter would be going off the edge, and raising a burr. So my intention here is to come across the front first and then go across the back in the other direction. So the cutting is always towards the interior of the copper block so we don't raise as much of a burr. And this should be just enough of a cut to clean up. And in fact, it's not cleaning up, so let me take a little bit deeper. Yeah, we got a little bit there that we missed, but we are cleaned up on the end here, so let's see how thick we are. Got some comments about micrometers not being in my top 10 tools video, so we'll use a micrometer today. In this case, it's actually easier than getting a caliper in here. Looks like another 9 thou would bring us to exactly 3/4 of an inch, which is what we want. So I'll take another 9 thou. And hopefully that will be enough to clean up that saw cut right there. If not, we'll go a little thinner. And you read that? Looks like we are under by 1 thou. I will take it. Now let me flip the other one over and do exactly the same thing, and I'll bring you back when we're ready for the next step. And incidentally, since I know I'm at my right dimension that I want, and I'm going to use the same parallels underneath, I went ahead and zeroed the quill DRO so I can come back to this 0 and I know the other one will be the same thickness. Okay, so I've already got one of these milled to length. I had the cameras on, but something microphone first world problems. So I'm going to mill the other one and you'll actually get to see it this time. So I'm gonna put in 2 parallels again. Same deal as before. We'll drop it in, and this time it doesn't have to be tapped down. In fact, I'm not going to tap it down because I don't want to mar the soft surface. I'm just going to make sure that we're clean here on the sides, and we'll just clamp it in place. Because all we're doing is milling the ends, and we don't have to worry about that in terms of parallelism. It's not going to be enough to matter. Except I don't want those to move anywhere, so you know what? I am going to tap it down. But I'm going to tap down on top of a brass shim so I don't mar the surface. Now I have swapped out for the insert end mill because it doesn't have a long cutting side for just a 2-flute carbide, or excuse me, a 2-flute high-speed steel end mill here. And I'm going to go down low enough that the tiny step that's worn in the end of this mill will be below the bottom of the part so I don't leave a track. And we'll start by just cleaning up this first side. First end. Okay, that's a good cleanup, and I hit the camera. So I've got this side cleaned up. The next thing I'm going to do is just zero my XDRO, and then we'll come down to the other end. Now, since I know this is a 1/2 inch cutter, and I want a 6.5 inch part, I need to add those two together, and I know I want on the DRO, I want my last cut to read that it's at 7 inches. That'll be 6.5 inches for the part, plus 1/4 inch on each end for half the diameter of the end mill. So part 6.5, tools 1/2, so end to end, 7 inches will give me a 6.5 inch part. So I'll just come in here and touch off, see where I am. looks like I got about 100 thousandths to go, so I'll do it in 2 passes. Take off 50 on the first pass. And I already know from doing the other end that this end mill on this mill with this copper will take a 1/2 inch or a 50 thou pass, no problem. And we'll come back and take the other 50. I'm going to lock the X Gibbs and we'll shoot a little WD-40 on here and we'll just take this cut and we should be good. Now, taking 50 thou depth of cut, there's going to be a lot of tool pressure, but it's a pretty sharp end mill, and let us see exactly how close we got. And honestly, within 2 or 3 thou is more than enough precision for this part. And there we go, 6, 4, 9, 8 and a half. So within 1.5 thou, just by trusting the DRO and doing the math on the end mill. Okay, we need to drill some holes in these parts, and while you weren't looking, I changed a couple of things. I swapped out the parallels. They were 1/4 inch thick parallels, and since we're going to be drilling through and I don't want to hit them, I swapped out for some 1/8 inch parallels. And the other thing I did is I got my stop attached to the end of the vise here, so that, because we're going to have to care about the X and Y positions, and so I want to be able to come up against that stop and make that repeatable. So I will snug this down. We won't go banging around on these because it turns out that even through the brass shim, I actually made a little, made some little dents in it, but you know, they're going to be dented up soon enough anyway. So the first thing I need to do is grab an edge finder. I also grabbed a drill chuck when you weren't looking. I don't know what you were doing, but I grabbed a drill chuck. Yeah, let me pick a speed here. I'd like to go about 1,000 RPM on this, and we should be good. Now what I'm going to do is I'm going to grab the top and the bottom, and I'm going to use the half function on the DRO to find the center, and I'm going to grab both ends and use the half function in the DRO, so I will have my 0, 0 at the very center of the part. And 1/2 X. Now let's just drive this thing to 0, 0 and make sure that it looks like it makes sense. That looks like that is the center. Okay. Let's do our first hole. Now these are going to be through holes. And this says it's 350. Which is about an S drill. It's a real loose fit to allow a lot of slop for adjustment or for misalignment of the soft jaw. So an S drill will be fine, and those are 1 inch, 188 thousandths each side of center. And I'm going to spot those first because I'm just going to push the S drill right through. Make sure that looks approximately right. That looks approximately right. Then we will push the S drill all the way through. Okay, and then the last thing we need to do is put some counter bores in there. Let me get the drill chuck out of here, and we'll come back with some end mills to do that. Okay, the counter bores around the hole need to be, it looks like 308 deep, and they need to be 625, so 5/8 of an inch. Now, if I had a 5/8 two flute end mill, I would just use that. I don't actually have that. I've got a 1/2 inch two flute, and we'll use this to run down to depth initially, and then I have a 5/8 insert end mill, but this doesn't cut all the way out to the edge because of the shape of the insert, but I think it will give me a flat bottom if I enlarge a 1/2 inch hole to 5/8. So that's what the plan is. We'll run the 1/2 inch end mill in first. And see how well this cuts. Again, this is the first time I've really machined aluminum, or machined copper. So this will be the first time we find out how plunging in works with this. If it grabs, if it cuts smoothly, we'll find out. So what I'm gonna do is I'm just gonna bring the end mill down. I'm just gonna lightly touch it to the surface, and I'm gonna zero this. Then we're gonna spin her up, and we're just gonna bring it in and go 300 deep according to the quill DRO, and we'll see how this cuts. I'm gonna put a little drag on the quill so that it doesn't get sucked in. Oh, this looks like it's gonna go okay. 100. 200. 300. Okay. Those look nice and neat. Now let me swap in the other end mill. Now this is 5/8 with inserts, and this is another Schar's special. I'll put a link to this down in the description too. Though let's see if it cuts first before you get too excited about going and buying one. We'll do exactly the same drill. I'll bring it down and just touch. Oh, that's crazy. It's within a 1/2 thou, or excuse me, it's within 5 thou of the other end mill. I got lucky. Okay. Now let's see if this one cuts as well. Well, let's put that back up on high. That one's not as awesome, but it's what I have, so it's what we're going to use. That was 300, and I think what's happening is it's not completely clearing, and so the chips are then getting caught underneath it, and it's kind of welding down. Though it looks like, yeah, it's just rolling around in there. It's going to come off. So, like I said, it's all I have, so this is what it's going to be. Nope. Okay, well, let's try going the other way. Let's try speeding it up. Let's try dropping the speed way down. Okay, there's the ticket. Well, here you can see a close-up of what we ended up with. Again, the top and bottom are the original mill finish, and the rest of the surfaces were machined. Holes look pretty clean. The counter bores look pretty clean, especially when you consider how I did them. I'm pretty happy with that. Make sure I don't have any chunks of copper that are going to get under the screws. Yeah, that looks a little bit better. So let's see if they fit. If I'd been real smart, I would have come and fit these off camera so that by the time I got here and you were watching, I would look smart because everything would fit. But as it is, I don't actually know if everything's going to fit. Let's find out. Well, those certainly seat solidly in the bottom. Let's see, is there any play or adjustment in this? A little bit. Try to center it up more or less on the casting. I didn't actually pay attention to how the original jaws came off, so. Great thing about this is if I have some error, it'll be systematic in both jaws since I use the same setup for both. So I'll be able to just flip the jaw over and get it to line up if I screwed up. Okay. Will they come together? Oh yeah? Yeah, that's pretty good. It looks like this one's just a touch high on this end. Let's see if I can adjust that down. Yeah. And this one on this end, see if I can settle it a little bit. That looks better. Oh yeah, beautiful. Oh, and they're nice and even on the ends too. Within, no, I mean it's a bench vise, right? But those are within 5 thou maybe less than that. Very, very nice. And if I really cared, what I would do is bring this together nice and neutral, and then grab a file and draw a file across the top of it. That is very nice. So if I want to grab a tool holder and drop it in here, oh, that is beautiful. That is nice and tight. Where with that much grip on the hard jaws against the hard flats on the tool holder, it was possible to move this around quite a bit. That's not going anywhere. Did it leave a mark in the copper? Well, not really. Nice. Very good. Well, that was my first experience machining copper, and this is C110, so it's kind of worst case as far as copper goes because it's almost pure. There are some other alloys like tellurium copper that are easier to machine. That's sort of their raison d'etre, is to be easier to machine, but this is just pure soft copper, and this will make a great set of soft jaws. And honestly, I don't know exactly what the temper is. I know that the C110 can come in different hardnesses. I assume it's half hard, whatever that means. Again, if I'm completely wrong about that, let me know down in the comments. But I think these look beautiful, and I think they are going to work beautifully as a set of soft jaws for the bench vise. Of course, when I want to use anything magnetic, I will have to put the steel ones back in. So I'll toss these in a tool drawer over with my other vise jaws, and they will be ready when I need them. Well, that's all I have for you today. If you enjoyed this video, if you learned something, please give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.